All right, guys, we're talking about arrays. Now, I bet you're pretty familiar with arrays from having taken like fundamentals in programming or something. Python uses lists actually, so if you're a Python expert and you're used to declaring something and then, declaring an empty list and then appending things to it, well, arrays aren't your bag for doing that because an array is fixed in length. Once you create an array, it is that size. And if you wanted to tack another item onto the end of it, you'd have to allocate another array that was longer and then copy the data in. So an array is a limited version of a class. What does that mean? It just means that once you declare an array, it's got a couple of methods attached to it, right? And it stores a group of data. And that data needs to all be of the same type, right? So you can declare an array of integers, an array of doubles, an array of floats, an array of, whatever. Any data type can be turned into an array. So to get a hold of an element in an array, you use the array name followed by these square braces and then a number. I'm going to start referring to this as its subscript. Occasionally index. People tend to use both names for it. This one's going with index, but I'm going to say subscript when I'm typing it. So this would be phone list subscript 0 is the first element in the array. Phone list subscript 1 is the second element. Phone list subscript 2 is the third, and so on. Let's get a NetBeans going. All right, so for week 16, what are we doing? Looks like we're on lecture V. Okay. What? 1613 lecture V. All right, so here we go. So I'm going to declare an array. I'm just going to declare it. I'm not going to allocate it. This is an array reference. It's going to be a reference to an array of ints. So I'm going to call it AI for array of ints. Now it's not an array of ints, right? If I try to put any data in it, that will crash because we have declared the reference to it, but we have not allocated it, right? If we want it to work so that it doesn't blow up like that, then we need to go ahead and allocate it. See right here it says array may not have been initialized. All right, so let's allocate it. AI is equal to new int, and I want to be able to store 5 numbers in it. So new int subscript 5. Allocate array, right? And then we can start putting values in it. And so on, right? How many could I put? Well, I can put 5 elements in it. But notice that the first element begins with 0, just like strings where the first character is at index 0. And so to get 5 positions, we can go out to 4, right? 0 through 4, because that will be 5, 0-based indexing. All right, so that's as high as we could go because we have now created 5, where we have now assigned 5 values to our array. Now, if you know your data in advance, you don't have to do it one by one like that. You can use an initializer list like this. Let's make an array of doubles. So I'm going to call it AD. And instead of doing a new and specifying a size, I'm just going to start putting some data in here. Like 1.0, and 2.2, and 3.4, and 5.6, right? And 8.9. There we go, right? We have initialized our array. It is also 5 items long. 1, 2, 3, 4, 5. It's 5 items long because that's how many elements are in the initializer list. So if we want to print that array, And there's an easy way. And if I asked you on a quiz or something to print an array using a loop, this would not be an answer with which would give you credit. But if you just want to dump an array to string, you can do this. System.out.println. And what am I going to print? Arrays.toString parentheses. Don't give me the spinning wheel of doom. There we go. AI, right? I don't know where you got as Liz. Come back here and do that again. Arrays.toString AI, right? And AI was supposed to be inside the quotes. Or if you wanted to separate it into two things, you could, right? You could make a string S that contains arrays.toString of AI, and then you could print that string out. And let's print out the array of doubles as well. Same way. S is equal to arrays. I don't know why that was so hard to type last time. ToString parentheses AD in parentheses semicolon, and then print that out. System.out.println S. So we'll see our data on the screen when we do that. I guess we could put quote AI equals end quote there, right? And then quote AD equals end quote there. Alrighty. So when I run it, it's going to print our two arrays. There's the AI array, and then there's the AD array. But really, how often is a user just going to want to see an array represented as something that's enclosed in square braces and separated by commas, right? You probably want something different. So let's make a loop that prints them out. For int I is equal to 0, I is going to be our index variable. I is less than the length of the array, ad.length, semicolon, I++. And then let's print out AI at that specific position. That's what we're going to be printing out. That was supposed to be AI. I typed AD. So system.out.println parentheses AI. And if we want to print the index number out as well, we could do that, right? Just so that we see, you know, what element is at 0 and what element is at 1 and so on. And there we go, right? Element 0 has a 3 in it. Element 1 has a 6 in it. Element 2's got a 9, and so forth. Now, if we just want to print it without that index counter, we would remove all of that. Now, if we're stepping through an array like that, there's a shorter form. It's called a range-based loop or a for-each loop. Honestly, I forget which one the book uses here. Do they call it a range-based? Doesn't seem like it. Okay, so a for-each loop has a similar syntax, but looks like this. For, and this is an array of integers, so my temporary variable needs to also be an int. And so what I'm going to do is say, for every integer v that is in the AI array, so for int v colon AI, so v will equal every value, and AI in turn, it'll equal a 3 and a 6 and a 9 and a 72 and a 44. Then print that out. System.out.print v, maybe followed by a space. Here I'm printing them out horizontally rather than vertically. And then I'm going to print a blank line at the end. So now when I run, it's going to print these numbers out like that, right? 3, 6, 9, 72, 44. So v is just a temporary variable that gets the value of AI. And since it is a temporary variable, it doesn't matter if you reassign it during your loop. If you wrote your loop like this, and then you set v equal to 7, for example, you thought you were erasing every element of the array and replacing it with 7s, then when you printed it again, it would still be 3697244 because this is a temporary variable. It is not actually the element of the array. On the other hand, this really is the element of the array. So I guess to make it look a little bit more like the other for loop so that they are exact analogs of each other, I'm going to make this one not have that space, and I'm going to make it a print ln. Right? So print ln v. Like that. So here we go. Here's the two ways of doing it. That's an index-based loop, and that's a for each loop, or a value-based loop. Use an index-based loop to display an array. Use a for each loop to display an array. And the same syntax you get to see used over and over and over. Like, what if we wanted to reset all the values of AD to 0? Right, we could do that. For int I is equal to 0, I is less than the length of the array, so ad.length, semicolon, I++. Well, here I made a mistake. That was unintentional. I'm printing out AI, but I typed in ad.length. This was supposed to be the array of integers. Well, anyways, these certainly need to match, because what if they didn't match? Let me comment this out and find out what happens if they don't match. Like, what if AD had more elements than AI did, right? It had 10.10 here, stuck at the end. AD has 6 elements now. AI has 5. And since we're using the length of AD, that's 6, and it's going to be trying to print a mystery 6th element, which doesn't exist, so it blows up. Exception in thread main, array out of bounds exception. All right, so why don't I make that AI like it's supposed to be? All right, so our loop to replace everything with zeros. AD subscript I is equal to 0, right? Just step through it with our index. How about if we want to add all the values of the loop? Well, I wonder if there's an arrays.sum feature. Nope. Because I'm thinking in Python, you could always just sum a list by doing that. I hope we don't have to do it. I mean, yeah, I'm going to make us do it the way, okay, fine. Here it is, with the Java Stream API. Well, gosh. That's a little bit more complex than I wanted to do. All right. Anyways, what we were going to really do anyways was write our own loop for summing the array. So if you're going to sum an array, you have to have an accumulator, right? Call it the total or the sum or something like that, right? And I actually like to make my total a double even if I'm adding integers together, so that when I calculate the average, I'm not worried that I'm doing integer math. Because if you remember, an int divided by an int gives you a whole number. And what if I want my decimal points and my averages? So my total is going to be a floating point type. And now, since we don't need to change the data, then I'm just going to use a for each loop. When you change the data, you have to have access to the subscript so that you can modify the value of the array. But if you're not modifying the values, then a for each loop is just as easy, and it's easier to type, right? There's that loop versus this one. I'd rather type that one. And as a matter of fact, that's what I'm going to do right now. So for int v, v stands for value in my mind, while I stands for index, for every int v in the AI array, add that to total. Total plus equals that value. Or if you wanted to do it this way, we could, right? Total is equal to 0. For int I is equal to 0, I is less than AI.length, semicolon, I++. Total plus equals AI subscript I in subscript, right? And then what's the average? The average is just the total divided by the length of the array. So the average is equal to the total divided by AI.length. Now I didn't print the total out, right? So I don't know. System.out.println total of AI is plus the total, and system.out.println average of AI is end quote plus average. Okay. Okie doke. So that seemed to work, and I guess that's an accurate average, right? You know, I'm not going to whip out a calculator and validate it. So what else can you do? We have this arrays class. Let's find out what it can do. Arrays dot. Well, heck, since we have our array and it's called AI, let's just type AI dot and see what it can give us. Length, well, that's interesting. Clone gives us a copy of the array. ToString, we played with that. And the rest of these, oh, and equals. You want to compare two arrays? I don't think that that's a good one. I think we would want to compare them item by item. I think that's just checking to see if the two references point to the same memory. No, that's not true. I'm sure that'll work. Well, let's find out. Let's find out. Let's clone that array, right? So int AI2, or excuse me, int AI2 equals AI.clone. And let's print out AI2 just to make sure that it's the same thing as AI was. System.out.println parentheses quote AI2 equals end quote plus arrays dot ToString parentheses AI2 in parentheses semicolon. Run. All right. So AI is 3697244. So is AI2. So let's find out if they're equal. But let's make sure that they are separate things. We're going to change one of the values. And what do I mean by separate things? Here's what I mean. I have that array AD, right? Which is an array of doubles. And right now it's all zeros. Right? System.out.println AD equals end quote plus arrays.ToString parentheses AD in parentheses semicolon, right? Now let's declare a new array reference, AD2, and I'm just going to say, okay, you're equal to AD. Oh, I have a copy of the array. I can do changes to it. No, I have two references to the same array, right? Just like I have two street signs to the same street, it's the same street. It doesn't matter that I have two street signs to it. I have two pieces of paper with my home address on it. You can find my home using either piece of paper. These are pointing to the same memory. So if I change a value in the array using this reference, like if I set that first value equal to a 99, and then oh, I put two equals. All right, and then I print out the original one again. It's going to show me that the original has a value of 99 now. Right? Got changed to a 99. But I didn't even change the original. I changed the copy. Well, it's not a copy. It's another reference to the same array. We now have two references to the same memory, and we can change them via both of them. So when we changed it via AD2, and then we printed out good old AD, then it got the same value that we had changed it to. That's why you have clone. You want to make a copy of your array, and it works like that. So now let's try changing an element of the clone and then printing out, just as a test. I'm going to change an element of the clone, AI2, I'm going to set it equal to 99, and then I'm going to print out the original again, right? Just copying and pasting that one. Oh, and look at that. It did change the original. Okay, obviously I don't understand what the meaning of clone means, because we now have, again, two references to the same array. So that is not how you want to make your copy. You'd want to use the copies class. Arrays.copy of, and we're going to copy our original. And how many elements do we want to copy? If we leave that off, does it copy the entire array? That'd be neat. Not so nice. All right, so AI, comma, and then how many do I want? I want all of them. So AI.length, right? And now AI2 is a copy, a whole fresh, complete copy unto itself. So changing out AI2, then when I print out the original, it won't be 99, right? Because we've changed the copy and not the original. All right. I am so sorry, gang. What am I doing wrong? I'm printing out AD. It's my variable names. They're too close together, right? This was supposed to be AI because I'm messing with AI. And you know what? So that clone probably did work. We'll have to go back and try it out. All right, so good. And then when we print out AI2, just to see the differences, we're going to see that AI2's first element has been set to 99. Right? So since we changed that element of AI2 to a 99, the original has been untouched. But how about clone? When we did arrays.clone, or excuse me, AI.clone, should have been a copy. And that is correct, right? The original was untouched. So clone did work the way my faith in the universe has been restored. So this is a good way of making a copy of an array. Or you can use that. So copying an array. You can use the arrays.clone method. You can use the arrays class arrays.copy method. Now, when I say the arrays.clone method, I mean like if the array was called AI, and you put like that, right? Or if the array is called colors, you put that. So maybe I'll just change that to .clone, right? You can use the .clone method, or you can use the arrays.copy method, or you can do it yourself. So in real production code, of course, you probably would not want to so-called do it yourself because, you know, you're writing code that's already been written by somebody else. You just want to use one of the ones that the Java API provides you. Let's say we wanted to do it ourselves. What do you have to do? To copy an array, you have to allocate a new array of the same length, and then to use a loop to copy the values from the source to the new array. So I'm going to make one called AI3. AI3. It's got to declare it. So int, and then the square braces means that it's going to be an array, AI3. And how long does it need to be? It needs to be the same length as AI, which is the one that we're copying. So int square braces AI3 equals new int. And what number am I going to put in here? I'm going to put the length of the array. Well, it's 5 long. No, that's horrible, right? Because what if I went back and I changed the length? So I'm going to use AI.length, right? That's step 1. Allocate an array of the same length, and then use a loop to copy the values. And since we need to know the index position, we can't use a for each loop for this. Why do we need to know the index position? So that we can copy AI3. I mean, here would be a really primitive way of doing it, right? Don't do it like this. I'm going to delete this, right? Right. I could do that, and then I could copy and paste that several times, and like that, and so on. Yes, that would be making a copy. But anytime you see something like that, you know that you're going to want to write a for loop. So for int I is equal to 0, I is less than the length of the array, ai.length, I++, and then what are we doing? ai3 subscript I equals ai subscript I. And let's print out ai3 now. Change that to a 3, change that to a 3, give it a whirl. All right, and so AI3 and AI contain the same data. Let's see if that dot equals will compare them. AI and AI3 should be the same. AI and AI2 are not. So, Boolean let's just do it with an if statement. So if AI dot equals AI2 parentheses system dot out dot println AI equals AI2, else print AI does not equal AI2. And let's do the same thing for AI and AI3. Because AI definitely does not equal AI2, because AI2 has that 99 there, but AI and AI3 ought to be duplicates. So I'm going to copy this. And change one of these to be 3. AI3, AI3, AI3. And there we go. It says AI does not equal AI2 and AI does not equal AI3. And I'm surprised that it's not saying that AI is not equal to AI3. I hope it's not just doing a check of its memory address, but it seems that that's probably what it's doing, right? What if we compared it to itself? Right? It does AI dot equal AI. Yes, AI equals AI, else AI does not equal AI. Well, that one's got to print yes, right? That one's got to confirm, print the positive, and it does. But if we wanted to do that, we could have just done this. If AI equals, AI, or whatever. If that's all that dot equals is doing, that's pretty lame. Well, how would you do a comparison of two arrays? You need to step through their value. But I bet there's a method inside the arrays class that'll do it as well. Arrays.compare, right? So you can compare two arrays, or maybe arrays.equals. You can compare two arrays that way. Let's give that a shot. So since I'm of the opinion that AI and AI3 should be the same, I'm going to copy that one. Well, this stuff didn't even work, right? So I'm going to delete it all except for that one because it didn't work. But instead of making it say AI equals, we're going to change the if clause. We're going to use the arrays class. So if arrays dot equals parentheses AI comma AI3, then print AI equals AI3. Forgot my closing parentheses. There we should go. Right? And it's true that AI equals AI3. Well, let's check out AI and AI2. Copy the same thing and compare it to AI2. instead of AI3, so got to change that, and that, and that. All right, there we go. Right, and so there are predicted results. AI equals AI3 and AI does not equal AI2. True enough. So how do you compare these things by so-called by hand? Well, you just start at the beginning and then you keep going until you find one that doesn't match, right? So let's make a variable called same or equal or something, right? And we're going to initialize it to false. No, we're going to initialize it to true. Innocent until proven guilty. And then we're going to use a for loop. For int I is equal to 0, I is less than the length of one of the arrays. AI.length, I hope they're the same length or else this comparison is pretty stupid. And then I++. Well, if they're not of the same length, it's going to check the number of elements matching the length of AI, and you better hope that the AI2 or AI3 has at least that many elements or it's going to crash. So, but we know that they're the same, so I'm not concerned. If AI at that position is not equal to AI2 at that position, right? Then they're not, oh, what? Then they're not the same, right? So equal equals false. And then break out of the loop. There's no reason to keep looking. And then we can check, right? System.out.println. Was AI equal to AI2? Question mark. Plus the word equal, our flag, right? Semicolon. And of course it's not. So was AI equal to AI2? False. It's not. Why? Because it stepped through the loop checking element by element. Is element 0 of one equal to the element 0 of the other one? Yeah, sure, if it is, then it doesn't do this. But finally it's going to hit one that doesn't match and set that to false. And if it gets all the way through the length of the array without ever having found one where the elements are dissimilar, then this variable will still equal true. And if I was going to be doing a lot of that and I didn't have the option of using the arrays.equals method, then I would make a method out of it, right? That would compare two arrays. So, you know, like this. Public static Boolean equal, right? And then it's going to take two arrays. It's going to take an array called A and an array called B. It's just going to have the same loop in it. So the return value is a Boolean, right? We're going to set it equal to false, and then we're going to have our loop. For int I is equal to 0, I is less than the length of A, so A.length, I++, and we will check if A subscript 0, subscript I, is not equal to B subscript I. In that case, they're no longer the same. So set ret val equal to false, and that should have been true to begin with, right? Innocent until proven guilty, and break out of the loop just for efficiency's sake. And at the end of our method, return the ret val. Maybe ret val is a stupid name. I think I will rename it. Refactor, rename it just to match. You can see that this for loop, this syntax, you just use over and over and over when you're working with arrays. We could have done the same thing to write our copy method, right? when I said do it yourself, and we did it like this, we could have written that as a method, right? Let's make a new array. I'm tired of dealing with those strings. Let's with that array. Let's do string colors equals red in quote comma, blue in quote comma, green in quote. And I forgot. I slipped into Python for a minute. We got to use curly braces. There we go. And I want to write a method that'll make a copy of that. I don't know why I'm writing a method to make a copy of it when I have the clone and the arrays.copy methods to play with, but I'm gonna. So public static, what does this need to return? It needs to return a reference to a new array. So it's going to return a reference to an array of strings. And I'm going to call it copy of. And what does it take? It takes an array of strings. And so then we have to do those same two steps that we talked about up here. When you make a copy, the first thing you do is allocate a new array equal to the length of the original, and then you copy the elements in one by one. So string, how about just B, right? So A is our original and B is going to be our copy, equals new string out to the same length of A, so A.length. Then our for loop. For int I is equal to 0, I is less than A.length, semicolon I plus plus, B subscript I is equal to A subscript I. And then return our new array. So string colors copy is equal to copy of colors, right? What are you complaining about? Unbalanced read-write with arrays. The array is only written to, never read from. Okay, fine. And now let's see if they're the same, right? So if equal colors, comma, colors underscore copy, system.out.println. Yep, they're the same. Because of course they should be. Now I've goofed up here. Incompatible types. A string. Oh, that's because I wrote this equal method to be ints. Well, I also want arrays of strings, so I'm just going to copy this one and I'm going to overload it by making one that also accepts arrays of strings. Right? What do you not like here? Use equals with null check ternary. No. Use equals. No. But they've got a point. These are strings, right? So we can't compare them like that. We have to do if A not, or if not, A dot equals parentheses B. Excuse me, A subscript I. Not dot equals B subscript I. Right? Or you could say if that equals false, right? It's a slightly less elegant way of doing it. Slightly less professional. The professional way would be to put the exclamation mark there to false. But we remember that to compare strings, we have to call dot equals. I'm going to go ahead and do it the more elegant way. Right? So there we go. Now we can compare both strings and ints. They match. I mean, we have one version of each. And that's okay in this language. You can't do that in Python. If you write two methods that have different parameter strings, then only one of them is active and the other one gets erased. But in Python you can't. Excuse me, in Java you can, and it's called overloading. I have overloaded this method name to accept two different types of parameters, both strings and ints. And now it does work. Right now. Now we should get, yep, they're the same. All right, what if we wanted to sort that data? We have these colors. They may not be in alphabetical order. It doesn't look like it. Colors. Let's sort the copy of it. So colors copy dot sort. Is that enough? Doesn't like that. How about arrays dot sort? There we go, right? Arrays dot sort colors copy. And then if we print that one out, and then we print the original, we'll find out that one of them is sorted and the other one is not. Now, why are we bothering using arrays.toString? Can't we just do this? It worked in Python, right? Can't I just print out colors? Well, no, we can't, because they did not override the toString method to make it produce anything pretty. All it says is java.lang.string and then this hashed memory address, right? So that's why we've been using arrays.toString or using loops to print out the contents of our arrays. But we can do that. Arrays.toString colors. And since we sorted the other one, why don't we print it out as well? So colors underscore copy. And there we go, right? Red, blue, green, red. What else do we have inside arrays? Along with arrays.sort and arrays.clone and arrays.binary search. What is binary searching? Once you have your data sorted, you can do a binary search on it. What does binary search mean? Well, you know the old guessing game. I'm thinking of a number between 1 and 100. Guess it. And let's say that that secret number is 32. Well, typically what you'll do is you'll start right in the middle. Between 1 and 100, okay, 50. And I'll say, no, that's too high. Okay, I better go lower. So I'm going to pick a number between 1 and 49. And how about halfway between those? That's 25. And I'll go, nope, that was too low. And you go, okay, well then I know it's not 25. It has to be between 26 and 49. And halfway between 26 and 49 is 37 or something like that, right? And so you keep cutting the range down by half each time. You guessed 50, you guessed 25, you guessed 37, and you keep zeroing in on it by cutting the list in half each time. That's what a binary search is, but for it to work, the data has to be sorted. How do you find an item in an array if it is not already sorted and you can't call that fancy binary search method? Well, with yet another loop. Boolean found equals false. Now we're going to step through the loop. Which one are we looking for? Well, let's look for the color green, right? So that's our target. String target equals green. Better be a capital G because I made my original data capital G. And then so for int I is equal to 0, I is less than colors.length, semicolon, I++. If we find it, if target dot equals that array element, colors subscript I, then we found it. Found equals true, semicolon. And we can increase the efficiency by doing a break there. Now, instead of just setting a variable equal to true or false, why don't I create a variable that holds the position of where it was found at? Oh, and the break should have gone after it, of course, right? You don't break before you set your value. So I'm going to make this an integer value called found at. And I'm going to set it equal to -1, and if it stays -1, it means we never found it, right? But if we do get a match, then we set our found at equal to our current index, right? And so when we're done with the loop, we can check. If found at is equal to -1, then it means we didn't find it. System.out.println target plus was not found in the array. Else it was, right? Else system.out.printf %s found at index %d \n end quote comma target comma found at underscore at. And since our target is green and it's in the list, we definitely should get this message. Right? Green found at index 2. Let's change it to something that's not in the list, like a lowercase g for green. Green was not found in the array. True enough. All right, seems to be working. Well, golly, I had to write that method. Whenever we've written something that involved a loop like that, we usually found out that there was an arrays class method similar to it. And there is in this particular case. Boolean, or what? Well, let's just type in colors dot. Nope, that's not finding it. Arrays dot. No, that's not finding it either. I'm looking for the equivalent of index of. To search the entire array. I love the name of that, splitterator. I'm really not finding it. I'm seeing binary search, but like I said, for binary search to work, you have to have the data sorted to begin with. All right, do a quick little bit of Googling here. So find the index of an array element in Java. You can do a linear search, which is just what I did. A linear search is when you start at the first position and you go to the end. And here they've written a function called findIndex that does that, right? Start at position 0 and then step through it, and if you ever find a match, you return that index position, else you just keep going, and if you never find it, you return -1. And then there's binary search. And then there's Guava, an open source Java-based library. Well, that sounds great. I'm annoyed to have to bring in something from somewhere to have to do this. I don't know why I've never looked for this before. And then the Stream API, a new abstract layer introduced in Java 8. Using Stream, you can process data in declarative ways similar to SQL statements. Okay, that doesn't look that easy. I'm more interested in this Guava one then. Below is the implementation of Guava. If we import com.google.primitive.ints, can we do it that way? All right, I'm getting annoyed by that. Yes, if we wanted to, we could write a method called find. So public, and it needs to return the int, the index of, and so it takes an array of some kind. Let's make a find for strings, right? Don't know why I called it AR here and just A here. Doesn't matter. And then we're looking for the target, right? So we need a target value. So we need a variable to represent our index. Int found at We don't even necessarily need that, right? Because we can just return the value of our index, or we can return -1 at the end, and return -1 means that we did not find it. Otherwise, we use our for loop. For int I is equal to 0, I is less than a dot length, semicolon, I plus plus. If target dot equals parentheses a subscript I, then we found it, right? So return I. So if we wanted to look for the color red, we could do that, right? So if find inside the colors list, comma, red is greater than or equal to 0, then it means we found it. And I forgot to make this static, so it's not finding the, there, that gets rid of that. System.out.println, we found red. Now we're not going to find red because these values are in uppercase, right? I mean, they have initial caps. So if we change that to an uppercase R, it'll work. What if we don't like that color red? What if we want to change it to a different word? I wish I hadn't done that. I liked having my output window the way it was. Okay, well, anyways. So int index is equal to find from our array the color red, right? And if index is greater than or equal to 0, that means we found it. And we're going to change the element at that position. Color subscript index. We don't like red, we want orange. And now when we print it out, system.out. Well, let's just use a for each loop. For parentheses string value colon colors for every string value that's in the colors list. System.out.println color place space end quote plus that value, right? Right? So color orange, color blue, color green. We replace the red. Alrighty. So array declaration we've talked about. When you declare an array, you just give it a data type, followed by the square braces and the name. When you want to create the array and not just declare it, you use the new keyword. So long arrows phone list equals new long, like that. Or you combine them into one statement, right? You don't have to declare them and allocate them in 2 different steps. You could just do that, right? That works just as well. And the next slide is going to say something to that effect. So it's legal to combine the arrays declaration. Provide a single statement that declares, creates, and assigns a 100-element array that stores book titles, right? Well, if it's going to be book titles, it's going to be strings. So string, whoopsie, string book titles equals new string, and how many of them I want? I want 100. Or you can use an initializer list. String students is equal to Zayed, Odebek, and Salom. When you create an array, with the new keyword, the values do get default values, unlike C++, where when you allocate an array, it's just got garbage in it until you initialize them. So the default value of an integer is 0. The default value for a floating point value is also 0. The default value for a Boolean is false, which is another form of 0. And the default value for a reference is null. Well, what's that mean, a reference? This will be about the last thing that we demonstrate today. What if we, well, not that. What if we declare an array of strings, but we don't actually allocate it, right? So, string array names. And we are actually going to allocate it. I didn't phrase that correctly. We're going to declare an array and allocate the array to make room for 5 strings. I forgot my new keyword. Now let's print it out. Let's use a arrays, string text equals arrays.toString parentheses the names. And let's print that text out. Did you see it? Null, 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 null. Why is that? Because strings are not primitive data types. A string is actually an object. And so we have created an array that can contain, or that does contain, room for 5 references. But we don't have any data in it yet, and so those references are null. It's not until we start putting data into it, like names subscript I is equal to quote George, right? And then names subscript 1 is equal to, Bill. Names subscript 2 is equal to Jimmy. I seem to be doing U.S. presidents from the 70s and the 80s. Because Clinton was the 90s, wasn't he? Anyways, there we go, right? Oh, well, I forgot to print it again. So if I copy these 2 lines, paste and delete the redeclaration of string, don't need to do that. Then we're going to see that the array now has some good data in it. Right? It's got 3 good pieces of data. It's not completely full. This is what's known as a partially filled array. All right, we're going to stop here. Let's go see if we already have something cooked up to do. All right. Make up my own. Didn't have it ready. So the homework. Write a program that creates an array representing book titles. It does not have to be 100, right? Representing book titles. Use an initializer list to give the array 5 values of your favorite books. Or you could call it movies, or make it an array of movies, or TV shows, or actors, or heroes, or, restaurants, whatever you want, right? Not going to a lot of restaurants recently. Is it correct to say foods? Right. Or whatever. Okay. So you know how to create an array. You know how to use an initializer list. We've done that several times. Okay. Then have your program prompt the user for a name of a book or movie or restaurant or whatever. And search the array using one of the techniques that we've talked about. You know, we even wrote a find method that you could, you know, use yourself, or you can just use a for loop. Search the array, and if that data that they chose, right, is in the array, print a message indicating what index that element is. Otherwise, print a message indicating that the element is not found. Okay? And to make sure that we know how to do the other things, write an index-based for loop to print the array. Write a for each loop to print the array, and then print the array using arrays.toString. Sort the array using arrays.sort. Make a copy of the array using arrays.copy. And then print the copy with arrays.toString. Why don't we move this to the last step rather than the first one? Or at least somewhere down here, right? All right. I think that's enough. Okay, gang. I'm going to do one more lecture, a little bit more about arrays that we want to do. And this semester there is no final exam, so just make sure that you get all the quizzes done. So I will see you next lecture.